Hello everyone, this is Dr. Song. Welcome to my YouTube video. So finally we can start the week 3 session from today. And from this week, you will learn a lot of things. They are really very important and the core content of the research course. So descriptive statistics that explains that how you will deal with your data when you receive your the survey results, and then you import in your SPSS the software, and then from there how you will deal with the data. That is first the data cleaning, and then you get some information from your data or physical data. So please listen to this course, and then we will continue the concepts theoretically, and then practically I will also publish the YouTube video so that you can understand. So, as a previous session, I just want to give you the references of the three courses and the three professors' name. So my course is based on those courses. So our learning objective for today is about the central tendency. So what is the mean and the median and mode? And also the variability. That means that how your data is dispersed. So range, like a minimum and a maximum score, and the variance is how much they are deviated from the mean, and also that is related to standard deviation. So we will know about this concept, and the percentile, quartiles, and the interquartile ranges. So that will be the next session. But already you know our learning objective of the week 3, box plot and outlier. So first that when we have our data, and then first thing what we do is a data cleaning, that is the frequency distribution tables. So we will obtain this table because we want to know how data are distributed and the information about the data. So let's assume we have the one survey. The participants were 100 people, and then from their answers about the many questions, that is the variables, so we will know how they answered according to the questions, and then we will proceed with the inferential statistic analysis. So before going to the analysis, we have to know how the answers from the participants are distributed. So first thing, what we should do about the central tendency. So what is the mean value? So when you say, you very simply say that average value. So 100 people, they answered the one question, and then what is the most frequently answered as a answer part? So that is the most frequently occurring score. That is the mode. So for instance, that is a female and the male. That is the gender variable, and then among 100 people, the most frequently occurring score was number one, let's say. So number one was the female, number two was the male. So this means that the majority of our participants were women. So that's why you need to obtain the central tendency. And this one is not affected by outliers. Why? Because we don't calculate the average score, but we calculate by the what is most occurring, frequently occurring. So that is not affected by outlier. That means the extreme score. You don't have the extreme score, just between the gender, is a male and the female. Or you can have a missing values, but we don't talk about that. We say that assuming that everybody answers the survey question, it will be between the 1 and 2. There will be no outliers. Not provide the information. So they don't provide the information about the variation of scores. So that is not the standard deviation, the average of the number scores. So that will be just the category, one or the other. That's it. They are mutually exclusive. And the median. So this is another way to see the middle. The central tendency. So median means in the middle score in the distribution. So when you put the all scores like a one line, and then that falls down in the median value. So that is a median. And then also this is not affected by outliers because that is a the it's a the not the sum of the total scores and then divided by the number of the participants. That is a mean. But median is not. That is just the retracing the what is in the middle situated. So that is not affected by outliers. And then when you have the one middle score, that is fine. But you have the two middle score, and then you can divide by two, so you can obtain the one middle score. And then the first number over the 50% of indicates the median. That means that when you obtain the frequency table, and then the accumulated the frequency that is over the 50, that is the median score. So let's see the what is the median score. You can see the data is like this, and then that is situated in the middle. So that is a median score. And the median score is particularly practical when you have the outliers. Like you see here, the salary, they have a very similar number, but suddenly that becomes the very high numbers. In this case, if you make the mean value, that is like average value, that doesn't reflect exactly the in the middle central tendency, because the high scores, they will give the effect to the low score. There are too much difference between them. So if we want to know the real middle score, you will know by the median, because even though they are the big scores with other value, but in the middle situated there is 15,000. So that reflects the more reality what is the middle value instead of obtaining the mean value. So mean value is very simply speaking, we know we do the everyday life average of the all scores. So you add the average score and then divide by the number of the participants. So this is the average score is a mean value, and this is very much used for numbers. So pure numbers, you can make the average. But this is very sensitive to outlier. Means that like in this case, yeah, when they have the outlier, means that it's very different from the other scores. And then when you add everything and then divide by the number of people, of course, this number will affect the other values. So that's why we say that this mean value is very sensitive to outliers. So when you detect the outliers, first option, you delete the outliers, or you will try to find the middle value, the median value. And then now we are going to the concept of the variability. So this means that even though you obtain the mean value, but we don't know how data is distributed. So how much they are deviated from the mean value. Mean score is 50, but other scores, how they are distributed from the mean score, that is the by the variability. So the range means that what is the maximum score and the minimum score, and then you subtract and then plus one, that will be your range. So the maximum score is 100 and the minimum score is 20. The range will be the 81. Okay, so that is the range. And then we will know about also the concept of the mean deviation. So mean deviation, it means that you will subtract the your score, individual score, from the average, and then you divide it by the whole numbers. So that is a mean deviation. You can see here, they have the difference between the mean score and the individual score. And then you put the absolute value. It's not a minus thing, because when you put a minus and the plus, that becomes the number is like a minus plus and very close to zero. So you will obtain the absolute value, and then you divide it by the people, how many people. So that is the like a mean deviation. Okay. So mean deviation, that is the way how you know like how much they are deviated from the mean score. And then that is explained, the deviance means that distance from the mean and then each score. So you can obtain that is like your score, individual score, minus the mean score. And then total deviance means that you add every single score, the difference, and then you will do the square. So that is the sum of squares. So that is different from the mean score. We are now obtaining the standard deviation. So that when you obtain the standard deviation, not the mean deviation, you will do this process. You will subtract the mean score from each score, and then you make that is a square number. So when you add the all square number together, that becomes a variance. So when you have the score deviation from the mean value, and then you make that the square number, and then you add the all square number, that becomes variance. And then you variance, and then because that is squared, and then you make the root, square root, and then that becomes the one number, that is a standard deviation. So in fact, the variance and the standard deviation, they are same thing, just this one is a squared number, and then this one is a root squared. So that is the only difference. And then you can see here in this example, when you obtain the like a sum of squares, so everything is a squared number, and then you make that with the is divided by the n minus one, yeah, n minus one, and then that becomes your standard deviation. Okay, so this is the okay, no, this is in fact this is the variance. So you divide by the n minus one, and then this is the variance, and then the variance that is the square number. So you will make the square root number. So that is the standard deviation. So you can see here more example with that. With the that is a variance. So you obtain the your individual score minus mean value, and then you make the square number, and then you divide by the whole participants minus one, and that is a variance. And then obtained from the variance, and when you make the square root, that becomes standard deviation. So this is the difference between the mean deviation and standard deviation, because you don't go for the squared score, just you divide by the n. So that is the difference. So why we do this, I will explain to you. Why we do this? Because the standard deviation is generally larger than the mean deviation. Okay, so standard deviation is larger, means that your distribution of the data is more, how can I say, more in reality. Mean deviation is more like some ideal position. Standard deviation is more reflecting the reality. If the difference is larger between the mean deviation and the standard deviation, this means that because there is extreme outliers. When it's extreme outliers, you can see that as you make the square number, of course, that standard deviation is greater. So that is the difference. So now you can see here the formula, like a sum of squares, and then you divide by the no, minus no, n minus one, and then you take out the square root. So that is the standard deviation. This is the variance, and then this is the sum of squares. So all these things are different formulas. So you will try to understand by studying. So sum of square, variance, and standard deviation, that represents the same thing. That is how much deviated the individual score from the mean. In that sense, they are same thing, but they have the different formula. So you have to know this. So the larger standard deviation means that is a larger variability. As I told you, standard deviation is in generally greater than mean deviation. Why? Because you make the square root, and then that's why the number becomes a square root and then divided by the n minus 1. So we will obtain the how much they are deviated from the mean score by that way. Standard deviation divided by the mean, and then the multiply by 100, that will give the percentage number. So when the percentage is higher, that means that the distribution has the big variability. So we can consider that is we will maybe count on less about the variability, because of the larger variability that is much more deviated from the mean. So that is the standard deviation. How that is noted is a mean value, and then just the next two you have to write what is the standard deviation. Standard deviation is zero, means that all scores the same number, same score. And then standard deviation has the three dimension. It's a standard deviation one is a 68%, and then standard deviation two is a 95%, and then 99% is a almost 100. So that is you will see that distribution next time. So that means that standard deviation is close to the mean. That means that distribution is very close to the mean. So we can count on that better. And then standard deviation is a very big. That means that the scores are very much deviated everywhere. So we will not count on that is a very well. So that's it. Let's see the next time.